More than 600 million years ago, long before dinosaurs, forests, or even fish existed, Earth was entering a remarkable new chapter in the history of life. This time period is known as the Ediacaran Period, lasting from about 635 to 541 million years ago. For most of Earth's history before this moment, life existed almost entirely as microscopic organisms drifting in the oceans or living within thin films of water. But during the Ediacaran, something extraordinary happened. Life began to grow larger. For the first time, multicellular organisms became common enough to form entire communities across the seafloor. These were some of the earliest large life forms ever to live on Earth. And although they were not animals in the modern sense we recognize today, they represent the first step toward the complex ecosystems that would later dominate the planet. The world they lived in, however, would look incredibly strange to us. At this time in Earth's history, the oceans were the center of life. The land above the water was still largely lifeless rock, but beneath the waves, something unusual was beginning to appear. Microbial mats were spreading everywhere, and these microbial mats were incredibly important to the Ediacaran world. They formed stable surfaces that covered large areas of the seafloor, providing both nutrients and structure for early life. Many of the organisms living here likely absorbed nutrients directly from the surrounding water or from the microbial mats beneath them. Without predators or fast-moving animals, these early ecosystems were calm and relatively undisturbed. Compared to modern oceans, the Ediacaran world was incredibly quiet. There were no fish swimming through the water. There were no shells or skeletons protecting animals. And there were almost no predators hunting other organisms. Instead, life existed in slow-growing communities spread across the seafloor. Many scientists describe these ecosystems as something closer to an alien garden rather than the active marine environments we know today. But this quiet world would not last forever. By the end of the Ediacaran period, major evolutionary changes were already beginning to reshape life on Earth. New types of animals were evolving that could move through the sediment itself, and those changes would soon transform the seafloor forever. The oceans of the Ediacaran looked very different from the seas we know today. Instead of coral reefs, fish, and complex food webs, the seafloor was dominated by thick microbial mats. These mats formed dense biological layers that covered large areas of the ocean floor. They stabilized the sediment and created a stable environment where early life could grow. Across these microbial mats lived some of the strangest organisms in Earth's history. Some organisms were flat and quilted in appearance, lying directly on the surface of the mats. Others were tall, frond-like organisms attached to the seafloor. Many of these organisms remained stationary for most of their lives. Some may have absorbed nutrients directly from the surrounding seawater, others likely fed on the microbial mats beneath them. Movement in these ecosystems was slow and limited. There were almost no predators in these environments. Without predators or burrowing animals, the microbial mats remained largely undisturbed. This created a stable ecosystem unlike anything in the modern ocean. To modern scientists, the Ediacaran seabed sometimes resembles an alien landscape. But this peaceful world was about to change. Among the many strange organisms living on the Ediacaran seafloor, one of the most recognizable is called Dickinsonia. Dickinsonia was a soft-bodied organism that lived between about 571 and 541 million years ago. Its body was flat and quilted, with symmetrical segments arranged along its length. Some Dickinsonia fossils are only a few millimeters long. Others grew much larger, reaching more than a meter in length. Despite its unusual appearance, Dickinsonia shows evidence of movement. As it moved, it left behind feeding traces on the microbial mats. These traces suggest that Dickinsonia was feeding on the microbial communities covering the seafloor. Instead of a mouth or digestive system like modern animals, Dickinsonia likely absorbed nutrients directly from the mat. For decades, scientists debated what Dickinsonia actually was. Some researchers once thought it might be a fungus. Others suggested it could belong to an entirely unknown group of extinct organisms. But more recent research has revealed an important clue. Chemical traces preserved in Dickinsonia fossils show molecules associated with animal life. These molecules strongly suggest that Dickinsonia was one of the earliest known animals. If that interpretation is correct, Dickinsonia represents one of the oldest animals ever discovered. But Dickinsonia was only one member of a much larger and mysterious community. And soon, the conditions that supported this strange ecosystem would begin to disappear. Dickinsonia was not alone on the Ediacaran seafloor. Surrounding it were many other unusual organisms that looked nothing like modern animals. Some of the most striking were tall, leaf-like organisms that extended upward into the water. One well-known example of these organisms is called Charniodiscus. Charniodiscus had a long stem that lifted a feather-shaped frond into the water above the seabed. The base of the organism was anchored firmly to the seafloor. From this anchor point, the organism extended upward into the moving water. This elevated position may have helped it collect nutrients from the surrounding seawater. Unlike Dickinsonia, these organisms did not crawl across the seabed. They spent their entire lives attached to the sediment. Entire communities of these frond-like organisms could grow together. Their shapes often resemble leaves or feathers. But despite their plant-like appearance, they were not plants. Many scientists believe these organisms absorbed nutrients directly through their bodies. Others may have filtered organic material from the water. Whatever their exact feeding method, these organisms depended on the stable environment created by the microbial mats below. As long as the seafloor remained undisturbed, these communities could thrive. But that stability would soon begin to disappear. New types of animals were evolving that could move through the seafloor itself, and those animals would transform the ocean floor forever. Near the end of the Ediacaran period, the ocean floor began to change. New types of animals were evolving with the ability to move through the sediment itself. Instead of living only on top of the microbial mats, these animals burrowed underneath them. As these early burrowing animals moved through the seabed, they disrupted the stable surface that had existed for millions of years. This change transformed the structure of the seafloor. Scientists refer to this shift as the Cambrian substrate revolution. Before this change, microbial mats formed a stable carpet across the ocean floor. After burrowing animals appeared, that stable surface began to disappear. The seabed became mixed and constantly reshaped by animal activity. For organisms that depended on intact microbial mats, this new environment was much harder to survive in. Many Ediacaran organisms had evolved to live on stable surfaces. When those surfaces disappeared, their ecosystems began to collapse. At the same time, new types of animals were continuing to evolve. These animals were more mobile and better adapted to the changing environment. The balance of life in the oceans was beginning to shift, and soon, an even larger evolutionary transformation would follow. Around 541 million years ago, the fossil record shows a sudden burst of new animal life. This moment marks the beginning of one of the most important events in the history of life, the Cambrian Explosion. By the end of the Ediacaran period, the quiet ecosystems of the ancient seafloor were beginning to disappear. Burrowing animals were reshaping the sediment, changing the environment these early organisms depended on. Many of the strange life forms that had dominated the Ediacaran world gradually vanished from the fossil record. In their place, new kinds of animals were beginning to appear. Around 541 million years ago, life on Earth entered a new chapter known as the Cambrian Explosion. The quiet alien gardens of the Ediacaran had given way to a world that was becoming far more active and complex. For more on early life on Earth, please like, subscribe, and ring the bell. This has been For What It's Worth.